Section 5.6 Inverse trigonometry functions. Differentiations. Definition. Each of the 6 basic trigonometry functions has an inverse function only on its restricted domain. The term arcsine of x is sometimes read as the angle whose sine value is x. An alternative notation for the inverse sine function is sine inverse of x. So for the function arcsine of x, its domain is a range of the sine function, which is -1 to 1, and its range is on the restricted interval -π/2 to π/2 inclusive. Similarly, for arc cosine of x, the domain is -1 to 1, and the range, notice the difference, is from 0 to pi. Arctangent of x has a domain from -infinity to infinity, and a range from -π/2 to π/2. Again, notice the similarity right here. And the arc cotangent of x has -infinity to infinity as domain, and the range is from 0 to pi. Arc secant of x has a domain with absolute value of x greater than or equal to 1. So the domain in the interval form is any number less than -1 or bigger than 1. And the range, and you recall, secant function is the inverse of cosine function. So we should expect a similar range from 0 to pi, except when y equals π/2, because when y equals π/2, we have 1 over 0, because cosine π/2 equals 0. So we have to exclude that one value. Similarly, for arc cosecant of x, the domain is absolute value of x greater than or equal to 1, and the range is from -π/2 to π/2, exclude the value 0. So this is a basic definition of the inverse trigonometry function. Let's take a look at example number 1 for the common exercise of how we can express inverse trigonometry function value with or without using a calculator. Now for part A, we are asked to evaluate arc cotangent of -√3. This is the same as asking what angle will give you a cotangent value of -√3. So arc cotangent of -√3 equals the angle where cotangent of this angle equals -√3. And we also need to notice the restricted domain is from 0 to pi. So this is the x-axis, y-axis, and we are only going to take value from quadrant 1 and quadrant 2, because that is from 0 to pi. But we also notice cotangent value is positive in the first domain. We notice the cotangent value is positive in the quadrant 1 and negative in quadrant 2, because we have a negative cotangent value. We know that the angle that we're looking for, this theta, has a terminal rate at quadrant 2. Now, in order to find this angle theta, we will need to recall cotangent of theta equals the quotient cosine theta divided by sine of theta. And all we need to look up is the unit circle. So for the angle right here, we will need the cosine value will end with a negative square root of 3. And the sine's value will end with a 1. Okay? Negative root 3 over 1 give you negative root 3. And this is also defined by the xy coordinate definition of trigonometry function. So this will equals x divided by y. So then, because we're more familiar with the cosine function or sine function, we would prefer to work with cosine or sine function. And by definition, cosine of theta equals x over r. Now we know x is negative root 3. How do we find r? Well, according to the Pythagorean theorem, okay, we have negative root 3 right here as the x value and the y value as 1. To find r from here to here, we just need to take the square root of 1 square plus root 3 square, which is 4. So r equals 2 in this case. And which angle has a cosine theta value, or which angle has a cosine value equals negative root 3 over 2? Well, this angle is 5 pi over 6, or 150 degrees. So that is the answer for part A. 5 pi over 6. Now let's take a look at part B. In part B, we need to evaluate tangent of arc cosine root 2 over 2. Well, arc cosine root 2 over 2 is a special angle. So what angle has a cosine value of root 2 over 2? Refer to the unit circle. Okay, that angle is pi over 4. So when we take the tangent of this angle, pi over 4, we should get the value 1. So our answer for part B equals 1. Now our answer for part C, I already give it to you. Okay, so it's cosine of arc sine of 4x equals what? Well, the answer is square root of 1 minus 16x squared. How do we arrive to this answer? So anytime you have an expression where you have to evaluate from the inside out. So we're given the information. Arc sine of 4x is the angle. What does it mean? That means this angle equals theta is an angle has a sine value equals 4x. And how do we understand this? Well, draw a right triangle. This is our angle theta. Sine is the opposite divided by the hypotenuse. So how do we get 4x? Well, it's just 4x divided by 1. And because of the Pythagorean theorem, we can calculate the adjacent side. Okay, the adjacent side is going to be the square root of the hypotenuse, 1 square, minus the other side of 4x quantity square, and that is square root of 1 minus 16x squared. And to calculate cosine, it's just adjacent divided by hypotenuse. So adjacent divided by hypotenuse. Next, let's take a look at the derivative of the inverse trig functions. Now, these are the formula that will be given to you at the appendix of the textbook. So let's try to understand this formula. Let u be a differentiable function of x. So that means u is an expression of x. The derivative with respect to x arcsine of u equal u prime divided by square root of 1 minus u squared. And similarly, we have the other 5 inverse trigonometry functions derivatives. So let's take a look at example number 2 on how to find the derivative of inverse trig function. So for part A, we have arcsine of t squared. So in this case, we would notice our u equals t squared. Now because the formula requires u prime, we might as well compute u prime. U prime is just 2t. So all we need to do is to be able to replace the u and u prime in the formula. So f prime of t will equals, according to the formula, u prime, which is 2t, divided by square root of 1 minus u squared. Okay, so it's t square squared, so t to the 4th power. That is part A. Part B, again, we need to identify our u, arctangent right here. Our u in this case is square root of x. What is the derivative of square root of x? Use a power rule. It's x to the 1/2 power. So power comes down. Power decrease by 1. And we can rewrite it as 1 over 2 square root of x. So for part B, f prime of x equal, according to the formula, u prime, which is 1 over 2 square root of x, all over 1 plus u squared. So 1 plus square root of x squared. You can simplify it and get 1. This is in the denominator, 2 root x. And the original denominator became 1 plus x, because square root of x squared is just x. So this is a derivative for part B. For part C, we notice that we have a product, x squared times arctangent of 5x. So we have to apply the product rule. Derivative of the first function, x squared, is 2x times the second plus the first function times the derivative of the second function. And in this case, our u is 5x. So u prime equals 5. Now plug in u prime, 5 divided by 1 plus u squared, so it's 5x squared, 25x squared. And we don't need to simplify it anymore. Okay, so that is a derivative for part C.